Kinetic Theory of Gases, Utme Chemistry, past questions 1978 to 1982. We've got the first one. UMA 1978 question number 1. Which of the following statements is correct? The average kinetic energy of a gas is directly proportional to its temperature. Of course, this is correct because the average kinetic energy of a gas is usually a measure of its temperature. So that is correct. Now, for the other one, we have UMA 1978 question number 21. We're told if 30 cubic centimeters of oxygen diffuses through a porous spot in 7 seconds, how long will it take 60 cubic centimeters of chlorine to diffuse through the same pot? If the vapor density of oxygen and chlorine are 16 and 36 respectively, I'm pretty sure this is a typo. It's meant to be chlorine. So we've got these options here. So we know from Gauss's law of diffusion that the weight of the first gas divided by the weight of the second one, of course, they will be inversely proportional to their density. So we have E sub 2 over, sorry, not E, we have O sub 1. So the weight of the first one, we know that's going to be the volume divided by the time. The weight of the second one is going to be the volume divided by the time, which divided by time. That is what we're looking for. So let me make our sub 2 the subject formula. So since that is the second gas, so we have our sub 2 is going to be equal to our sub 1 rho square root of rho E sub 1 divided by square root of rho E sub 2. So that is going to be equal to the weight of the first gas, which is oxygen, is going to be 30 divided by 7 times the square root of the first one. The square root of the first one, the square root of the density. The density of the first one is 16, all divided by the square root of the second one. The square root of the second one is going to be square root of 36. So let me just quickly figure that out. Using my calc here, I've got 30 divided by 7, that will be 4.2 times the square root of 16, that is 4, divided by the square root of 36, which is 6, and that will result to 2.857. And since this is the weight of the second one, so that implies that V sub 2 divided by T sub 2 is going to be equal to 2.857. Just taking it to 3 decimal places. So we've got that. Then we've got if we make T sub 2 the subject formula, that is going to be V sub 2 divided by 2.857, and V sub 2 is 60. So we have 60 divided by 2.857, which will be equal to, let me get rid of this, then I've got 60 divided by 2.857, which is equal to 21.0000 blah blah blah. So I've got 21.0000 blah blah blah, which is of course option C, which stands for correct. So the next question, UMA 1979 question number 35. Which of the following statement is true? An increase in the temperature of a given mass of gas increases the number of gas molecules. An increase in the temperature of a given mass of gas increases the number of gas molecules. Of course, no, that is wrong. Mass is always constant. An increase in the temperature of the gas does not affect the kinetic energy. Of course, an increase in the temperature of the gas does affect the kinetic energy, so that is wrong. An increase in the pressure of the gas is proportional to increase in volume. Nope. We know from Boyle's law that pressure and volume are inversely proportional. A decrease in the pressure of the gas is proportional to the increase in volume at constant temperature. Yup, I think this is the answer. As for D, a decrease in the pressure of the gas is proportional to increase in volume at constant temperature. That is Boyle's law. So let's just check the last one. A decrease in the pressure of the gas decreases the number of gas molecules present. No, this is absolutely wrong. So the correct answer is option G. Then the next one, which is UMA 1979, question number 36. The vapor density of a gas may be defined as the mass of a unit volume of the gas compared to an equal volume of water vapor. Nope. The mass of a unit volume of the gas compared to an equal volume of hydrogen. Yes, because for vapor density of a gas is usually compared to an equal volume of hydrogen, mass of this over mass of equal volume of this. So hydrogen is out of here. So the correct answer is option B. And the next one, which is UMA 1979, question number 45. A gas occupies 30.0 cubic decimeter at STP. Okay, what volume would it occupy at 91 degrees Celsius and 380 millimeter of mercury? Okay, a gas occupies this, so we have V sub 1 is 30. Let me just write that as 30. At STP, that is the temperature, T sub 1 is 273 Kelvin, and while the pressure is 760 millimeter of mercury. So we got that. Now for V sub 2, that is what we're looking for. Now we've got T sub 2 as 91 degrees Celsius, which we need to convert to Kelvin. So we'll add 273 to that, and we should be able to figure that out as 273 plus 91, that is 364. So we've got 364 Kelvin, and the P sub 2 is 380 millimeter of mercury. Okay, so we're now going to go about this, which is the general gas law, which is P sub 1 V sub 1 over T sub 1 equal to P sub 2 V sub 2 over T sub 2. And we're looking for V sub 2, so we'll make V sub 2 the subject formula. And okay, let me just quickly do that. V sub 2 is going to be equal to P sub 1 V sub 1 T sub 2 over P sub 2 T sub 1. So I think the only thing we need to do right here, okay, we don't need to convert since they are all in DMQ. So we have V sub 2 is going to be equal to P sub 1. P sub 1 is 760 times V sub 1 is 30 times T sub 2. T sub 2 is 364, all divided by P sub 2. P sub 2 is 380 times T sub 1. T sub 1 is 273. So let me quickly do that, and I will be having 760 times 30 times 364, then divided by 380, then divided by 273. So that will result to 80 decimeter, cubic decimeter, which should be option D. So for that is option D. The next question, which is UME 1980 question number 4, 10 cubic centimeter of carbon dioxide is mixed and sparked with 100 cubic centimeter of air containing 21% oxygen. If all the volumes are measured at STP, the volume of the resulting gases would be. Okay, now if CO reacts with oxygen, of course it's going to react with oxygen because it's not going to react with the other guys. So it's going to give us carbon dioxide, right? So we have carbon dioxide, and let's try to balance the equation because we can't work without a balanced equation. And we've got 2 oxygen here, 2 oxygen here. That one is cool. So we've got carbon here, but we only have 1 oxygen here. So in order to make this easy, you just put 2 here. So you have 2 carbon, 2 oxygen, then you have 2 carbon here. So then 2 times 2 is 4. So we have 2 oxygen here, 2 oxygen here, making 4 atoms on both sides. So that one is good. We have that. And okay, so based on Lucas law of combining volume, we've got 2:1:2, and 100 cubic centimeter of air contains 21% of oxygen. So for us to get the oxygen percentage of oxygen, the volume, it's going to be 21% or 21% of 100 cubic centimeter, which is going to be 21 cubic centimeter. So we know that 10, this is what is actually happening. 10 is reacting with 21 cubic centimeter to give us what? Now, if you think about it, this is twice of this. So that implies that 10 of this requires 5 cubic centimeter of this. So if 10 to 5, then this is going to be, since this is 2 to 2, this is going to be to 10 to 10. So we have this. Now, since we are looking for the resulting gases, now the resulting gases is going to be 10 cubic centimeter of this. This the resulting one from the product. This is the product. Now recall that we have 5 out of this. So that implies that if you take 5 out of this guy, that is going to be 16 cubic centimeter. So 16 cubic centimeter of oxygen then react with carbon dioxide. So that means this guy too is also a residue. So we've got this guy, and okay, the resulting gas. Now also remember that for all the gases in this guy, which is 100 cubic centimeter, 21 out of it is the oxygen. So that implies that the remaining 79 out of this, remaining 79 cubic centimeter also will be part of the resulting gases. So we've got 10 plus 16, that is 26. Now 26 plus 79, 26 plus 79. So here we've got 5, we've got 1 in here, 3 plus this, so we've got 105 cubic centimeter, which is going to be option C, which stands for correct. UME 1980 question number 11. Under high pressure, real gases do not obey gas law, because their molecules, of course, have become more energetic. We increase the pressure, of course, you definitely know from P sub 1 over T sub 1 equal to P sub 2 over T sub 2. That is the Gay-Lucas law. Now, I'm not talking about Gay-Lucas law of combining, volume. Now, I'm talking about the Gay-Lucas law. Now, for this one, the pressure is directly proportional to the temperature. And, of course, that means, of course, it's going to be more energetic, which is option A. Now, for the next one, UME 1980 question number 12. 500 cubic centimeter oxygen was collected over water at 30 degrees Celsius and 552 millimeter of mercury pressure. What is the volume of dry oxygen at STP? Vapor pressure of water at 30 degrees Celsius equal to 32 millimeter of mercury. Now, we know that from Dalton law of partial pressure, we know this is going to be this, but once a gas is collected over water, the total pressure of the gas is going to be the pressure of the dry gas plus the vapor pressure of water. Vapor, let me just put that as V, P sub V. So that means the pressure of the dry gas is going to be the total pressure minus the vapor pressure. So for the first case, the total pressure is 752 now minus the vapor pressure of water, which is 32. So you work this out, this is going to be 0, this is going to be 2, this is going to be, we have 720 millimeter of mercury. So 720 millimeter of mercury is actually the pressure of the dry gas, in this case the oxygen. So we've got that done and dusted. Now the other thing now is this: we want to know the volume of dry oxygen at STP. So we have V sub 1 is equal to 500 cubic centimeter. T sub 1 is 30 plus, we have 273 because we need to convert to Kelvin. So we have 3, we have 0, we have 1, that will be 3. So we have 303 Kelvin, that will be T sub 1. Then P sub 1 is what we just figured out, which is 720 millimeter of mercury. Now, V sub 2 is what we're looking for. Now, T sub 2 is at STP, which is 273 Kelvin, and P sub 2, which is 760 millimeter of mercury. So we have that. Now, just like we have we use the general gas equation, P sub 1 V sub 1 over T sub 1 equal to P sub 2 V sub 2 over T sub 2. So P sub 2 is 760. So we have 720 times 500 times 273. Then we have divided by 303 divided by 760. And that will result to 426.7, which is approximately, that should be 427, and that is option E. That is for that. The next one, which is 1980 question number 13, we are told which of the following statements is an exception in the assumption of the kinetic theory of gases. Gases are composed of many elastic particles. Of course, we know that is true. For that, the particles have negligible size. Yes. The particles are in constant random motion. The particles have negligible mass. Nope. This one is the correct for this one, because this is an exception to the assumption in the kinetic theory of gases. Of course, gases always have mass. That is why their particles rather do have masses. That's why they always say For a given mass of gas, the pressure is directly or inversely proportional to this for Boyle's law. For a given mass of gas, the volume is directly proportional to absolute temperature. So you get the gist. So that's for that. And for the next one, which is 1982 question number 3. The pressure on, I'm pretty sure this is meant to be cubic centimeter. The pressure on 100 cubic centimeter of oxygen gas at 35 degrees Celsius is 750 millimeter of mercury. What would be the volume of the gas? A lot of typos here. If the pressure is increased to 1000 millimeter of mercury without changing the temperature. Now, if the temperature is constant, we all know we're dealing with Boyle's law. So that is P1 V1 equal to P2 V2. So here is I'll just do it quickly. Since we are looking for if the pressure is increased, what will be the volume? Okay, we are looking for V sub 2. So V sub 2 is going to be P sub 1 V sub 1 over P sub 2. So P sub 1 is 750 times V sub 1, that is 100, divided by P sub 2, that is 1000. So this guy is going to cancel this guy will cancel this guy. That will be 75 cubic centimeter, which is option C, which is for correct. Now the next question, 1982 question number 4. When the pressure cooker is half filled with water and heated to boiling point, then the pressure inside the cooker will, of course, the pressure will increase, because for a pressure for it increases, increase because the water vapor molecules now strike the walls of the container tube more frequently because of their increased velocity. Yes, this makes, of course, this is correct, because you know, as the temperature increases, the saturated vapor pressure of water will increase. But in this case, if for the pressure to increase, once the pressure, like you are asked, then the pressure inside the cooker will increase, of course, because the water vapor molecules now strikes the wall of the tube more frequently because of their increased velocity. Of course, that is the reason, because this guy has been heated to boiling point. That's the reason, because of course, more often than not, when we analyze saturated vapor pressure, it's usually in a confined container for the analysis. But I believe you get the point. So that is for that. The next question is UME 1982 question number 23. If the rate of diffusion of oxygen gas is taken as 1, what will be the rate of diffusion of methane, whose relative molar mass is 16? Okay. The rate of diffusion of oxygen over the rate of diffusion of methane is equal to the square root of, for methane, over the square root for oxygen. The relative molecular mass of oxygen is the molar mass of oxygen atom is 16. So for oxygen gas, remember it's a gas, so it has to be 2 atoms. So that'll be 16 brackets 2. I believe that should be given, but anyway, we have the rate of diffusion of oxygen is taken as 1. So we have 1. Let me just make this guy the rate of methane the subject formula. So I've got the rate of diffusion of oxygen, which is 1, times square root of 16 square root of 2. I'm just using salt to split that, divided by the square root of 16. So this guy is going to cancel this guy. Then I will have the root of 2 is 1.4. which is option C, which stands for correct. So we have the next one. UME 1982 question number 24. If the temperature of a gas is increased, the kinetic energy of the molecules will decrease? Nope. The pressure will decrease if the volume is constant. Okay, the pressure will decrease. We know that the pressure is meant to increase from Lucas law. This is directly proportional to this, so that is out of the way. The gas will occupy a greater volume if the pressure is constant. If the pressure is constant, that means we are talking of Charles' law. This guy is directly proportional to this, so yes, this goes for this, which stands for C, correct. Yeah, and that's the end of this lecture. I am your tutor, SB Sanni, and you can check out our website at www.sbelucidation.com for study materials. See you all next time. God bless.